In the lessons leading up to this lesson, we've learned about categorizing matter in different ways. First of all, we learned about the three building blocks of matter: atoms, molecules, and crystals. Then, we learned about pure matter, which is one type of building block, and mixed matter, which is made up of different building blocks that aren't bonded together. Next, we learned about the two types of pure matter: elements and compounds. And I told you there was going to be one more level. We're going to look more specifically at matter still as we look at the types of elements and the types of compounds. And that's what we're going to start doing in this lesson as we look at a type of element known as the atomic element. Now, I want you to just remember this as we're learning about the types of elements. We're going to be looking at types of matter that are so pure that we're sort of peeling back the layers of what God created and looking at something that He didn't show us all the time in nature. These pure substances that we're going to be looking at are things that human beings have figured out creative ways to purify so that we can see them in their purest elemental form. And it just gives you a sense of awe and wonder as we look at the beauty of what God created by looking at its most basic units that make it up. So as we learn about atomic elements, keep that in mind. We're looking at the pieces, the pure pieces that God made the universe from our understanding of science. Let's take a look at atomic elements. But first, before we go to atomic elements, let's start off with a slide that you've seen in a previous lesson as we compared compounds and elements. Remember, compounds have more than one type of atom, and those atoms can arrange themselves in different ways. They can either be in crystals, they can be in molecules, they can even be in really long repeating molecules known as polymers. But the defining characteristic of a compound is that it's made up of more than one type of atom, whereas an element is just one type of atom. And it would seem that an element would just be one simple thing because it's only one type of atom. However, that one type of atom can arrange itself in three different ways. And those are the three types of elements, the three ways that a single type of atom can arrange itself. If you look carefully at this slide, at the pictures of elements on the bottom, you'll notice that there are three different ways that the atoms arrange themselves. In this lesson, we're going to be looking at the type of element that is shown by argon, which is an atomic element. Now, the word atomic element sounds a little confusing at first. It sounds really technical and difficult to understand, but it's really not that bad. If we break it down into its parts, I'm sure you can understand the meaning. An element is simply a pure substance that's made up of just one type of atom. Atomic means that the substance is made out of atoms that aren't bonded to other atoms around it. Remember, an atom is the fundamental unit of matter. It is the smallest piece of a substance that is still that substance. And we call a substance an atomic element if it's made up of the same kind of atom, and those atoms aren't bonded at all to other atoms in any way. So an example of this is argon, which is made up of individual argon atoms that fly around freely as a gas, and they don't bond to other argon atoms. This would be an atomic element. Another example of an atomic element would be something like radon. Radon is a very heavy elemental gas. It's sometimes found in people's basements, and if it is found in basements, it's really bad for people's lungs. It's actually the number 2 cause of lung cancer in the United States. Radon is an elemental gas made up of radon atoms that aren't bonded to each other. So because it's one type of atom and those atoms aren't bonded, we would call radon an atomic element. The next 3 substances I'm going to show to you are not atomic elements, at least not yet. Take a look at these 3. Here we have bismuth, which we've seen before, solid gold, and solid silver. All 3 of these substances are elements because they're just one type of atom, but if you look at the picture and the way the atoms are arranged, There's a crystal lattice in the background. There are bonds between these atoms, and because there are bonds between the atoms, they can't be atomic elements. Atomic elements are made up of unbonded atoms. We can change each of these substances, though, into an atomic element by heating it up past its melting point. Look what happens to the atoms of bismuth as I heat bismuth up past its melting point. The atoms lose that crystal lattice structure, they don't have any bonds anymore, and they begin to slide past one another. The same happens to gold when you heat it up to its very high melting point of right around 2,000 degrees Fahrenheit, and silver, which also has a very high melting point. Notice that when you heat up these solid crystal elements to the point that their crystal lattice breaks apart and the atoms begin sliding past one another, the atoms aren't bonded to each other anymore. These are all atomic elements. Here's an interesting question. Do you see any solids in this mix of atomic elements? Did you notice that there aren't any? They're all either gases or liquids. If you think about it, a substance can only be a solid if the particles are attracted to each other enough to hold them together in a fixed shape. And where does that attraction come from? It comes from bonds. And if there are no bonds, as an atomic element isn't allowed to have any bonds between the atoms at all, if there are no bonds, you can't have a solid substance. So atomic elements are always going to be either liquids or gases. They're going to be made up of one type of atom, and those atoms are never bonded together to other atoms, not even in a crystal lattice.